You can go ahead and delete that last footage.
The sun's not even up yet as I start my commute. Also interesting to note that when we show up to do our 100 hour, there's going to be an entire crew of guys who are just getting off work who spent the whole night doing a 100 hour on a different plane. It's just how much we're flying right now. There's night shift.
Hey, why it look like those little balls you stick them in?
AC, jet center run.
For coffee. What's up, guys? Today we're going to be doing a 100-hour inspection, and I'm in charge of the airframe side. James will be doing the engine. And this is what my checklist looks like. Pretty basic stuff.
Vincent's working on the airframe inspection. I'm doing the engine inspection.
So I'm about to do the boot's operational test. I have the input for bleed air hooked up to, instead of bleed air, it's shop air. I'm about to go turn the switch on and watch the boots inflate, and I'm gonna inflate them to a 1-minute cycle. And basically what that means is within a 1-minute period, the boots are gonna inflate in a sequential pattern. First, the horizontal stabilizer will inflate. Then in about 8 seconds, the lower inboard boot will inflate. And there you can see the upper portion of the boot inflate. And the reason for this is so that it can break off the ice in a way that won't disturb airflow. Found a leak, guys. Usually what I do when I find a leak is I circle it. So there you can see I circled it with my pen.
Alright, I've gathered up all my tooling. Now it's time to get started with the inspection. First thing I'm going to do is check the airframe fuel filter for any debris. Go ahead and clean it and reinstall it.
So now I'm setting up for the stick pusher operational test, and our stick pusher is basically an attitude correction system. It prevents a stall by using inputs from these angle of attack indicators. When the angle of attack of the plane becomes too steep, the system will actually start pulling. It will first shake the stick to notify the pilot of an impending stall, and then the stick will start pulling like so.
We have to do a leak check, which is to make sure that the O-rings are seated and that no fuel is going to leak from the filter when the pumps are on. Hey Vince, can you give me a leak check? Okay. No leaks.
So I'm about to get to the most crucial part of the stick pusher test, in which James is going to help me out. He's going to go outside and move those angle of attack indicators to certain degrees in order to check both the shaking of the stick and the pushing, and you'll see what I mean just by that. Dude, you need a mount for this.
I got this one.
Oh, you got that one? Alright, he's got the other one going.
Yeah, you can show him what's going on in there.
Yeah, I'll show him what's going on in here.
Alright, help Vincent with the stick pusher.
And he's about to move, and as you can see, he's only moving the left side.
And we should feel the stick pusher actuate, so the wing will shake a little bit.
Here we go. So the tolerance is 31 degrees plus 1 minus 2.
And it was pushing at about, shaking at about 32 degrees, so that's within the limit. Now this one I'm going to do the same thing with on the other wing, and after I do that we're going to actually test the pusher system.
Stall.
Okay, so that one went at 31. Now Vince is going to give me the signal, and I'll move this one fully up with this one.
James is going to move the right side fully up, and the left side is going to be moved up too. So now the plane thinks that it's about to stall.
40 degrees, you'll see the pusher actually.
This is the button I press to interrupt the pushing of the stick.
Stall. 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 Stall.
Put this other one back down.
Both of the angle. Hold on.
Stall.
It pushed at 41 and it stopped pushing at about 30.
Angle of attack indicators have to be at the right at the threshold degree to shake and push the stick.
Started at 41 and stopped at 30.
Perfect.
Right on point.
Right on point.
Next up, we're going to inspect the #1 generator brushes. That's this component here. All this ducting is just to provide ventilation to the generator when it's running. Keep it cool, basically. But yeah, we're going to pop that cover off and check out the brushes. Here's what they look like. This is a wear indication on the brushes. As long as you have it showing on one brush, it's acceptable for continued use. There's the inside of the generator.
I'm going to be testing the horizontal stabilizer trim. And as you can see right here on the lower MFD, this is the horizontal stabilizer. These are, and this matters a lot. It's used often. So to move it, I have to hold the trigger and move this China hat switch. And as you can see, the trim will move. And the color of the aircraft symbol will change from green to white, and that means that now it is out of the takeoff range. Next part, I'm going to be testing the interior and exterior lights. And this plane is lit like a Christmas tree. There's your right hand nav. This is your flashing recognition light, your landing light, and your taxi light. And that red flashing light on the bottom is your lower beacon.
This is my iRed. I just took a direct hit with alcohol to the eye.
I'll be checking the integrity of these seats. First thing I look for is the recline. It's done by pressing this button. Check the seatbelt. Check the swivel. Then I'm going to check the attachment bolts on the bottom.
So I'm about to do a borescope inspection of the compressor rotor. And basically inspecting each blade for any cracks or defects. And we do that with this small camera, which we can insert into the engine. So here's the borescope, and then you can see on this screen, you can see there one of the compressor vanes, and we'll basically maneuver the borescope around until we've looked at each individual blade.
That's going to be done up there.
It's like a spark plug on your car, only a much higher voltage spark plug. Just looking at the wear, comparing that to the wear limits, and then we'll do an operational test, make sure they spark. Okay. Pretty serious spark. That's how you jack a plane. We're getting ready to do a compressor desalination wash, which basically means we're going to pump fresh water through the compressor and compressor turbine to rinse them off. We're going to use shop air to cool off the generators. and Vince is going to be on the inside. He's going to go ahead and crank the engine and then give me a hand signal of when to introduce water and then a hand signal when to stop. It's going to get loud. Okay. Now we're going to do the compressor turbine. That's about it. Since these propeller blades started to come out of feather, set the circuit breaker, the prop system circuit breaker, and they'll come back into feather. Just watch the propeller blades. Pretty cool. Vince and I are about to do the engine run, which is the final and probably most important part of the 100-hour inspection. Got dark on us. Busy day. This video took me longer to get posted than I had hoped. Been a busy couple of days. So I realized I never really explained what the 100-hour inspection. Basically every 100 hours that we fly one of our aircraft, we need to do a detailed inspection. And so that's what this was. This was a 100-hour inspection. So we have flown this plane for 100 hours. We complete the inspection and now we can fly another 100 hours before doing another inspection.
This next part, I'm going to be checking the safety of these seats. Delete that part, James.